Okay, Algebra 1, we are looking at section 4.3, writing functions. So before we talked about how a function is a special type of relation. Every input has exactly one output. So with this input and output, we have different variables. We have an x and a y. Independent and dependent function rule and function notation. So I'm going to leave this up to you guys to fill out. They are at the beginning of your chapter, so that's where I want you to put your vocab words. The independent variable and the dependent variable, we're going to talk a lot about those today. The independent variable is independent of everything else. So this is kind of your input. I'm just going to put a couple little words here. So your independent is your input. This is also your x variable, and it has an effect on the dependent. Your dependent variable you can think of as your output. The independent variable affects the dependent, and then this is your y variable. Your function rule is just like what happens to x. So I'm just going to put these in our words. What happens to x? And function notation, we're going to talk about that later. Okay, so the first type of problem, it says determine a relationship between the x and y values and write an equation. You have done this before. Basically, you're asking yourself what's happening to x to get to y, what's happening to 1 to get to 5, 2 to get to 10, 3 to get to 15, 4 to get to 20, and it has to work with every single one. So I think you guys can probably see that if you multiply the x by 5, you'll get your y. So you're going to take 5 times x. Your input are your x values, 1, 2, 3, 4. Your output are your y values. Okay? When it's given like this, I personally prefer to see it in a table. So I would even take my ordered pairs, 1, 3, 2, 6, 3, 9, 4, 12. That really helps me see what happens. So what's happening to your input or your x values? Well, looks like it's being multiplied by 3. So y equals your x times 3. I prefer to put my number in front of my variable. That's just how you write equations, so I just practice like that. And then letter C. What's happening to x to get to y? Sometimes they might be trickier, but and they're not always multiplication. So look at here, like sometimes I take ones that I like instead of working with negatives right away. So I know that if I took 4 and I subtracted 3, I'd get 1. 3, I subtract 3, I get 0. 2, I subtract 3, I get -1. And 1, subtract 3, I get this. So your y equals your x value, take away 3. So your input was 1, 2, 3, 4. Your output was -2, -1, 0, 1. Okay, so now we're going to talk more about independent and dependent variables in situations. So remember, the independent is kind of like what affects the dependent. So in the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So we have two factors. We have electricity used and the temperature. So do you think the electricity affects the temperature or the temperature affects the electricity? So I think the temperature affects the electricity. So the amount of electricity used depends on if it's warm or cold or hot outside. So the next one is the cost of shipping a package is based on the weight. So the cost is one factor, and then the weight is the other factor. So the weight of the package is what affects the cost. So I'll read it back. The cost depends on the weight. The electricity used depends on the temperature. The faster Ron walks, the quicker he gets home. So we have walking speed as 1. And then the other factor is the time it takes to get home. So sometimes the factors or the variables are just taken right out of the equation. Sometimes you kind of have to read into it a little more. So what could change, and what is the independent versus dependent variable? So here I feel like the time it takes to get home depends on how fast he was walking. So the time depends on his walking speed. Okay, apples cost 99 cents a pound. So we have the total cost and we have the number of pounds purchased. So the independent, kind of when you go to the grocery store, you kind of have a choice. How many pounds do I buy? So that would be the number of pounds. Doesn't even matter that they're 99 cents right now because we're not solving anything. And the total cost depends on how many pounds you have. Now, some people will flip this around. They'll be like, well, I only have $5. So how much money I have determines how many pounds you can buy. But that's not what we're talking about here. We want to know independent, dependent. Okay, so now we're going to talk about writing functions and function notation. Now, this is something that when I was an 8th and 9th grader, this really confused me. But as I've gotten older, I realized that it's not really that complicated. Function notation is just a funky way to write a y, okay? And it says the dependent variable is a function of the independent variable. So y is a function of x, and we know that. Whatever you put in for x affects your y. So what they do is they start in algebra, they start replacing y with f of x. And the reason they do this is because you will start to have more than one function in different problems, okay? So in these 4 problems, we're going to have 3 parts. You have to identify the independent and dependent variables and write an equation in function notation for each situation. Okay, so a lawyer's fee is $200 per hour for her services. This is just like what we did on the other side. So I'm going to do independent, dependent, and then we're going to write the equation. So for the independent is the number of hours we need this lawyer's services. So independent is the number of hours, and the dependent is the total cost. And like I said, read this back to yourself. Total cost depends on the number of hours. So if I were to write an equation, this is the function of x. What is x? X is the number of hours. And maybe I'll just put this little over here. This is our x, and this is our y. Okay, so that means that $200 times the number of hours that we're working gives us this. And the reason why they do this is because now, instead of having a whole bunch of different y's, we're going to write this, oh, if she needed the lawyer for 2 hours, you would have 200 times 2. So the function of 2 hours is 400. And I know this is looks really confusing because you're like, oh, you're not multiplying this? What this is doing, this is showing you what number you put in there for x. So x was 2, and we got $400. So it shows you what we got for that. So these are your 3 answers. So the admission to a local carnival is $8. Each ride costs $1.50. Now, sometimes you get a problem, and you might have a harder time thinking of the independent, dependent. Okay, so sometimes writing the equation is helpful. So we have our function notation. And so we have to pay $8 to get into the carnival. And then we have to add on the cost for each ride. We don't know how many rides we're going to go on. So the total cost is a function of how many rides. So your 2 things. The independent, what you kind of could control, is the number of rides. And the dependent is the total cost or the total spent at the carnival. And then there's your equation. Stephen buys lettuce that costs $1.69 a pound. Okay, kind of like what we did before with the apples. The independent would be the number of pounds. The dependent is the total cost. And I know the total cost seems to be a pretty common dependent variable, and that's true. So in function notation, we're going to write f of x equals $1.69 times x. Basically, where you had a y, now you're writing an f of x. An amusement park charges $6 parking fee plus $29.99 per person. So independent, dependent, again, the total cost depends on what? Is it how many people or how many cars? What is it? It's the per person. So my f of x is going to cost us $6 for just parking, and then however many people you can get in your car, you do have to pay $29.99 times the number of people. Okay, the last little part here, our evaluating just means to solve. So we're going to solve these. So this is why we start using f of x, because we're going to solve this little function twice. We're going to do it once when there's a 6 and once when it's 7.5. So when I write this, I'm going to put f of 6. And the reason I put f of 6 is this is just so if someone was looking at my answer, they'd be like, oh, when you put 6 in, you get 30. So when the function was evaluated for 6, we got 30. So then our other one, we're going to put 7.5 in. So that's going to be 5 times 7.5. F equals f of 7.5. And I'll just really quick, 5 times 7.5. And I get 37. So this way, when somebody looks at some functions, they're like, oh, when you put 6 in, you get 30. When you put 7.5 in, you get 37.5. So you can kind of see the effect of what happens when you change numbers. Okay, so for our next one, we've got g of t. G of t is the same thing as f of x. The t is our input. The g of t is our output. So don't worry about when they switch numbers on you there. They're just trying to expose you because later on you will get different types of problems. So t is 2. So I'm going to put a 2 in here. And then I'll do this problem again, and I'll do, well, I should have put a 2 here too. G of negative 5 equals 230 times negative 5 plus 10. Okay, so 2.3 times 2 plus 10. My 0 doesn't always want to work. 14.6. So this is g of 2 equals 14.6. And that's how you'd express your answer. And then we're going to have negative 5 times 2.3 equals plus 10. I get a negative 1.5. So g of negative 5 equals negative 1.5. So when someone looks at my answer, they know what number I put in for x. They don't even have to see the full equation. Okay, our last one here, I have h of x. Again, a different number, it's okay. I'm going to put a 12 in for 1. So 1/2, I'm going to put a 12 in for my x. And then my other one, I'm just going to write it out right away, as a negative 8. So 1/2 times negative 8 minus 3. The biggest confusion that I notice students have is they think they actually have to do some math over here, and they don't. This just tells us what h of 12 is. So h of 12, just leave that. Half of 12 is 6. 6 minus 3 is 3. So h of 12 equals 3. And then I have h of negative 8. Half of negative 8 is negative 4. If you have negative 4 and you take away 3 more, you end up at negative 7. Last type of problem, they just kind of want you to do multiple steps at one time. So it says find a reasonable domain and range of each function. They give you a word problem, and I have 4 steps for us to do here. So it says Manuel has already sold $20 worth of tickets to at the school play. He has only 4 tickets left to sell at $2.50 a ticket. Write a function. So we have to write a function to describe how much money Manuel can collect selling tickets and find a reasonable domain and range for the function. So remember, domain is our x, range is your y. So to help us out here, identifying an independent and dependent. So our independent and our dependent. So we want to know how much money. So the money collected depends on the number of tickets sold. So depending on how many tickets he sells, that determines how much he will be able to collect. So we're going to write a function, and I'm going to put this in function notation. So it looks like he has already sold $20 worth of tickets, so we have $20, and he has some tickets left to sell, and it's going to cost us $2.50 a ticket. So $2.50 times the number of tickets he sells plus the $20 he already has will be his total collected. So remember that the dependent is your f of x and the independent is your x. And then determine a reasonable domain. So why they say reasonable is because we're limited in this problem. We are limited because he only has 4 tickets left to sell. Can he sell partial tickets? No. Can he sell negative tickets? No. So a reasonable domain would be 0. He could sell 0 tickets. He could sell 1 ticket. He could sell 2, 3, and 4. But that's all. And I'm just going to put over here that these are tickets. So it says use the determined domain to find the reasonable range values. So basically we're just going to put these in and find our y. And so if I did that, and then I'm probably just going to do these in my head. If I put a 0 in, he wouldn't get that 250. So our range values are for 0 is just going to be 20. For 1 ticket, it would be 22.50. For 2 tickets, that'd be $5. It'd be 25. For 3 tickets, it'd be 27.50. And for 4 tickets, it would bring us up to $30. So, independent, dependent, this is your x, this is your y. You can also think of this as your f of x. Writing the function, domain is our x values. Range are the y values, or f of x values. Okay, just trying to make everything clear there. I know you guys are going to have questions, and that's okay. So I just hope you guys took some good notes.